Hi y'all, welcome back. So in this part 4 of the video, we'll see what term we have left. So as I mentioned in the previous video, in this case we have 3 terms left instead of 1. Usually the pressure gradient equals 0, like the previous analysis. So let's write all that down and set them equal 0, okay? So you just have 0 equal to negative 1 over r times partial p over partial theta. Okay, plus mu times partial of r, partial with respect to r of what? 1 over r times partial of r times u theta over theta r. Okay, and then plus mu times theta over z square. Now, this this equation right here is very tough to solve. I would say it's solvable. There's a lot of technique you can solve things like this if y'all interested. One technique is called finite element methods. I'm not sure, so let me write down. So can be solved numerically using finite element method. This is the topic that the professor is really interested in. If you can have a discussion with him, please feel free to do so. Unfortunately, I don't have a strong knowledge of this topic. In fact, I never do a finite element methods analysis before. So, but it's something that's really interesting, and I think you definitely you can talk to your professor or you can look it up by yourself and have an interest in it and see where it can take you, see where you can apply. But for this particular problems, to get an analytical solutions, we will have to make additional assumption. We have to simplify things further. So let me write down. You can see, unfortunately, I really don't know how to solve this system analytically. So we need further assumption to make the system simpler. Okay, so what assumption we will make? Okay, the first assumption we will make is that, let me see. Okay, y'all remember part A? Okay, let me go back to part A. Oh, actually part B. Okay, you remember u theta can be a function of r. It can either be a function of r or can be a function of z. I think this is part 1 or part 2 videos. You can go ahead and check, but it's week 11. Okay, this is the chance we can dictate the destiny of u theta. Okay, let's dictate the destiny of u theta. We know that u theta can be a function of either r or z, right? Okay. Let me see, I'm gonna scroll up. Okay, yeah, r, z. Wonderful. So in order to make our life simple, we'll say u theta is a function of r. In order to make our life easy, we say u theta is a function of R. Okay? Why? Because if u theta is a function of R, it means that u theta is not a function of z. It means that the partial of u theta over partial of z equals 0. Okay? And then that being said, we can cancel this term out. U theta over square over u theta square. So you can say u theta square over u z square equals 0. Okay? Because the derivative equals 0 means that the second derivative also equal to 0. Now, so this is a very interesting risk because you dictate z. You can choose u theta to be a function of R, so that the equation gets simplified. So that's being said, this term will cancel out. Okay, I can write this because of assumption 1. U theta is a function of R. Okay. Okay. The next assumption we can cancel out is this term right here. The reason why we can, because we can. This is the most usually this is, I'm not really sure, but usually these term right here on the second, this term right here, this term right here remains if you want to solve for it, because the pressure usually it equals 0 if there's no flow in that direction. So let me see the previous analysis. Let me see. We haven't do okay. Yeah, so we can say there's no pressure variations. Okay. Yeah, we can make that's the second assumption. So you can say assume pressure P, okay, not vary in the azimuthal direction. Okay, so partial P over partial theta equals 0. Okay, so you see in this problem, remember part A, we say that u theta is can be a function of R and Z. We can choose it. So we choose u theta as a function of R, so that u theta square of partial over partial of z square cancel out. We choose the mathematical terms for our benefit. Okay. And the second assumption is we say there's no pressure variations in the theta directions. Okay. Now, with that being said, you only have left with one term, right? You have the mu terms. So you can say the equation simplify to, so mu times partial of R, which partial with respect to R of 1 over R times partial of R times u theta over u theta R equals 0. Okay, so how you solve this system? First of all, you cancel mu both sides, so you have partial with respect to R of 1 over R times partial of R times u theta over partial of R equals 0. Okay. Okay. Treat this as something. Okay. Treat this as a, let's say this is y. So if you have partial y over partial R equals 0, you say the y equal C1, right? Because it's like solving a basic differential equation. Yeah, like you have dy over dx equals 0. You have y equal constant, y equals C1 or y equals C. So similarly, you can say that this whole thing right here, this y term, So 1 over r times partial of r times u theta over partial r equal to C1. Okay. Okay, let's us times r both sides. So if I time r both sides, you have partial r times u theta over partial r equal r times C1. Okay, wonderful. Now what we have next? So you can integrate both sides. Okay. I would say this. For the sake of simplification, you can treat this theta right here like a d. So remember how you solve for this, right? You have, let's say you have dy over dx equal to let's say x squared times b, right? So you solve for it like this. You say dy equal to dx times x squared times b, and then you integrate both sides, right? You integrate both sides, dx times x squared times b. So you have y equal to x cubed over 3 times b plus c. Okay, so similarly we can solve the partial like this. So you can time both sides by the theta r, and I will write d characters. So I will write, actually, you know what, I can keep the partial. Let keeps everything original. So r times u theta equal r times c1, and then you can integrate both sides. So you have this one become r times u theta. The second one become dr over r is r squared over 2 times c1 plus c2. Okay. Wonderful. Can you find u theta? Yes, you can. If you divide both sides by r, you have u theta equal r over 2 times c1 plus c2 over r. Okay. And that's it for the fourth part. In the next part, we'll plug in the boundary condition and see we can find the specific solutions for this problem. Okay, but this right here is your theta component of the velocity. Okay, and we have confirmed, you know, this is a good confirmation, because you remember what we say later on. We say u theta is a function of r, right? This is just logic. You state something is true, you say u theta is function of r. Later on, after all the things you've been through, later on you get u theta is a function of r. So if you state a logics and later on you get a true statement, it means that your original logic is correct. So this is a good news. I'll make a note here. You say we also verify that u theta is a function of r. Okay? In the next video, let's see what is C1 and C2. See y'all in the next video.